Okay, today's video is S.4 Piecewise function word problems. And we can go ahead and just get into the goal today. We know how to calculate and evaluate functions. We learned that in the previous lesson. So today we're going to interpret a piecewise function in the context of a real-world problem. There aren't any key terms today because we've already identified what a piecewise function is. So we can go ahead and get into the first example. And with any word problem, what you're going to want to do is just read it first. As we go through, I'll write the steps down here, but there aren't very specific steps to word problems because each one may be asking you something new. A new shop, Bill's Burgers, opened up in town. Bill's decided to offer a special deal to promote the shop's opening. The cost for a large meal will be sold at a reduced price, and in parentheses it says prices may vary based on time for the first month. The cost of a large meal is expressed as a function of time measured in days since the 4th. So what you're trying to do is you're trying to figure out what's the problem kind of about. Well, we know that the problem is about buying a meal from Bill's Burgers, and we know that they're comparing the price versus the time. So prices are going to change based on time. So your first step here, and I'll go ahead and give you the question. If the question is asking you what days offer the cheapest meal, we know that we're going to have to convert this math to words to figure out what day is going to offer the cheapest meal. So that's what our first one is. Step 1 is to convert math to words, and we're going to use a timeline to do this. You'll see in a second what I mean when I say that. So I'm going to take this piecewise function and I'm going to so C of t, if we know t is obviously time, the other thing that we're comparing is cost. So C of t, we know our output is going to be cost. So we can say that the cost of a large meal is equal to, and now we're going to convert this piecewise function into more understandable interpretation. So on our previous lesson, this 8, or these numbers on the left of the comma, were equations, right? And then these numbers to the right helped us figure out which equation to use. Well, if our output is based on the equation and our output in this example is cost, then this 8 is referring to the cost. There's no variable here, so we know that the 8 is just a constant number, and we know that cost is in dollars, or we can assume that it is. Now what do these numbers over here mean? So we know that the cost is $8 from 0 to 5, and 0 and 5 are both included. So what is 0 and 5? Well, it tells us, it says that we're measuring time from July 4th. So 0 would be 0 days from July 4th, which would be July 4th. So we can say that if we go on July 4th, we're going to pay $8 for the large meal, right? However, this isn't the only day that we're going to pay $8. We're going to pay $8 between 0 and 5 days from the 4th. So we've got to figure out 5 days from the 4th. Well, all we have to do to figure out what 5 days from the 4th is just add. If 4th is our 0, we're just going to add 5 days to it. We get 9. So from July 4th through the 9th, we're going to pay $8. That's what the 0 and the 5 is. So this would be 0 days from July 4th, right? And then the 9th would be 5 days from July 4th. Now the second part, our equation has a variable in it. So it's going to vary based on the time that we go. We know our times are whole numbers. We've got to figure out what these dates are. What's the smallest number that I can plug in to this inequality? If it says 5 is less than t, which is greater than 10, we know that the number that we cannot put in is 5 because there's no equal to. So the smallest number here is going to be 6. So 6 days from the 4th is what date? So we're going to take the 4th, we're going to add 6 days to it, and we get 10. So we know that 6 days, which is the smallest number we can plug in the middle, is going to be the 10th. So from July 10th, and it makes sense that we're picking up where we left off in the last one. So from July 10th, which is 6 days, all the way till, and the smallest or the largest number that we can plug in here is 9. So we can go ahead and add 9 to the 4th, and we get 13th. So from the 10th to the 13th, which would be 9 days, right? We're going to pay, and this one varies. So if we plugged in 6 to T, we would get 9. So on July 10th, we would pay $9. And if we go on the 13th, which is 9 days from the 4th, we would pay 9 plus 3 would be 12. So if we go on the 13th, we'd pay $12. So for this middle equation, these days, we're getting a varied price based on when we go. And for the last equation, again, it's a constant, it's just 15. So when it's $15 from 10 days from the 4th, would be the 14th. That makes sense. See how they're kind of leaving off where the previous one was? So from the 14th, which is 10 days, right? And it's equal to, that's why we added the 10, to the, and we've got 29, but the smallest number that we can put in here isn't 29, it's actually 28 because it's not an equal to. So we can take the 4th, go ahead and add 28 to it. We get 12 here, and we get 32. So 32 obviously isn't a day in July because July has 31 days. So we minus the 31 days of July, we've got 1 day left over. Well, the next day after the 31st would be August 1st. So this is actually taking us into August 1st. So between the 14th of July and the 1st, we're going to pay $15 for this large meal. So if the question's asking us what days offer the cheapest meal, we know that the days between the 4th and the 9th offer us the cheapest meal. Now you might see another question that says calculate C of 6 minus C of 5. Well, we know how to do that, so let's go quickly and calculate what C of 6 is. We're going to plug in 6. 6 fits into the middle one. 6 plus 3 is 9, so we know that C of 6 is 9, and we're subtracting that by C of 5, which plugs into the top one because it's an equal to, which is 8, which is just 1. Calculating, very, very easy. Well, now it's asking us, what does subtracting these two mean? Well, we know that 6 days from the 4th, and that kind of gets a little confusing, was the 10th, right? Because 6 plus 4 would be the 10th. So we're taking the cost of a large meal from July 10th, versus the 5th, 5 days from would be the 9th, versus the 9th. We're figuring out the difference, referring to the subtraction, in cost, because C of t, right, C of 6 and C of 5, those were costs. We're finding the difference in cost between these 2 days. Let's go over one more example today. Whoa, gotta close the first one though, unless you want to go to it one time. Change the color of the marker. I'm going to go ahead and read this. Go ahead and try this on your own if you think you can. In order to gain popularity among Desert Edge students, Edge Theater plans to offer a special promotion. If you show a student ID, the cost of a ticket in dollars at Edge Theater as a function of time measured in days since April 1st may be described as. It gives us the function. So let's go ahead and convert this into words. The first thing we're going to do is we're going to convert the 1. We know that we're talking about cost. And we know that we're talking about days from April 1st, right? So these are all days. So our cost here for the first, or the top part, is going to be $1. And 0, obviously, is going to be our April 1st. And I'm going to put April for you. And 5 is an equal to, so we're just going to include that. So we add 5 to the first, 5 plus 1. 6. So we know that this is from April 1st to the 6th, right? Or from 0 to 5 is going to be $1. And then from the smallest number we can put in here is 6, right? So we've got from the 6th, we got the 0 to the 5th, we got from the 6th to the 8 is included. So 8 days, or 6 days from the 1st would be the 7th. So from the 7th to 8 days from the 1st would be the 9th. So from the 7th to the 9th, or 6 days from to 9 days from, the cost is going to be, and because we've got a variable here, we're going to input the 6, so 6 plus 1 would be 7. So if we go on the 7th, it's going to cost us $7. If we go on the 9th, which is 8 days from, 8 plus 1 is 9, it's going to cost us $9. So the cost here is between 7 and 9. And then our last equation is the bottom one, which is $10. And it's from the 9, because 9 is the smallest number we can put in the bottom inequality, all the way to 10 is the largest one. So from 9 to 10, and I should actually put the dates here, right? So from 9 to 10, 9 plus 1 would be the 10th. So from the 10th all the way to 10 plus 1 would be the 11th. From the 10th to 11th, it's going to cost us $10. So which one has the cheapest option? From the 1st to the 6th would be our answer. Go ahead and calculate C of 9 versus minus C of 8. So we're finding the difference in cost from when we go on the 9th versus the 8th. Oh, my bad, I read this wrong. I wrote this wrong. 9th is 8 days from, so this should be an 8 right here. This is 9. This is 10. Okay, I confused myself. Too many numbers. So C of 9 would be 9 days from would be the 10th. So this is the difference in cost between the 10th versus the 8th would be the 9th versus the 9th. Right? If we go on the 10th, how much are we going to pay? We're going to pay $10. Minus if we go on the 9th, how much are we going to pay? We're going to pay $9. The difference would be 1. Good luck on the homework.